Imagine this, it's 2:30 a.m., your plant is running smoothly and suddenly your SCADA screen freezes, pump trips and entire operation stops. The SCADA system has stopped responding and nobody knows why. So in this video, we will understand why SCADA system fails and the most importantly, how to prevent such failures. Let's start. So basically we have worked on multiple automation across the plants and utilities, and we have noticed that SCADA system failure never happens due to one issue. So we have break down all these reasons into 6 major categories. Hardware related issues, software configuration, network and communication, field devices, cyber security, human and operational errors. Let's understand each one clearly. So first one, hardware related issues. When SCADA runs on a PC, anything like hardware or operating system problem can cause the downtime. Common root causes include hard disk failure, power fluctuations, overheating, RAM issue causing the system hang, window crashes, or any forced update. So in lot of plants, SCADA computer is kept in a dusty environment. Cooling fan gets blocked and CPU overheats. So in this way, system shutdowns and SCADA system fails. Next one is a network infrastructure. So SCADA system relies on network infrastructure for real-time data communication. If network fails, entire data stops, and the main causes are damaged Ethernet cable, malfunctioning of the routers and switches. In this section, the third point is signal and IO cards. So IO card may be damaged due to electrical surge. So we know that when mechanical modifications are going on in the industry, they may use welding without turning off the control panel or PLC, or malfunctioning of the UPS or unhealthy power system. It may cause electrical surge. Next one is power system instability. So here UPS failure, unstable power supplies can cause the voltage fluctuations. The next one is HMI panel degradation. So when we are using very old HMI, so in that HMI maybe touch element may fail. So if display fails, so it may prohibit operator to use the machine. So we have to remember that we have to protect these hardware like a critical component. Now next issue, software and configuration issues. So we know that in the SCADA software, we are using PLC tag, historical data logs, trends, alarms and reports. So if database grows heavily without maintenance, so SCADA slows down and it freezes. So common root causes are SQL log files growing uncontrollably, excessive alarm configuration, insufficient storage, faulty scripts and garbage code. So while developing a software, we have to think all these points so that our historical data, it should not grow uncontrollably. Also, this garbage code, we have to avoid this garbage code or infinite loops, so that it may increases our downtime of the machine. So now let's say for one of our client, SCADA was running fine for almost 3 and 4 years. So one day SQL log file reached up to more than 50 GB. So it was filling the C drive because SQL server, that software developer, he has configured and stored on the C drive. So it reduces the operating system free memory, and SCADA stopped logging and data lost. Now next point, network and communication failures. So the main reason is electrical noise interference. So this noise on the Ethernet cable, if it enters on the Ethernet cable or Modbus lines, it may cause transmission errors. So these caused due to high voltage lines or instrument cables and communication cable, they are carried from the same cable tray. Next is IP address conflicts. So duplicate IP address present in the network, so it may bring down the SCADA automatically. Also, weak and unstable WAN connection, it may hit real-time monitoring aspects of the SCADA. Next one is firewall and port blocking. So if user misconfigure the firewall, then it may block the PLC and SCADA communication. In lot of industry, IT IT department, they may install lot of their softwares to block the external communication or internal communication. So this may block the PLC and SCADA communication. Now next one, field devices and instrument issues. So everybody knows if sensor gives false reading, SCADA shows false reading. Even 1% drift in the pressure transmitter, it may runs PID harder, motor runs hotter, and it is a fantastic invitation to the failure. So wrong data is more dangerous than no data. Also, wall and actuator jamming. So these mechanical wear, corrosion, debris accumulation, so which may prevent smooth operation of wall and actuators. So this may increases downtime in the production. So like these walls and actuators, there are a lot of MCC components. They are, so it becomes wear and tear due to repeated cycle. So next one is cyber security and unauthorized changes in the PLC and SCADA. So cyber security. So this is basically goes for the SCADA. So cyber attack. So how cyber attacks happens? So they may encrypt your critical data and disable the operator access to the system. So which may halt the production. The next one is unauthorized logic modification. So verbally changes to the PLC and SCADA, it may invite infinite uncontrolled loops in the PLC and SCADA application. So which results in interruption in the production. So always we have to remember that there should be proper documentation or change control policy for the modifications. Next one is a human and operational errors. So many SCADA failures are not due to technical thing, but they failure because of the human error also. So common mistakes: incorrect mode selection while operation, bypassed safety interlock to pass the production, ignoring warning alarms, operator operators are not trained to handle alarms in the system left with the default password, or password sharing with the other operators, less important to the less importance to the preventive maintenance and preventive actions. So in lot of industry, operator uses USB drive to copy reports from SCADA PC. So USB carried malware, usually USB carries malware or viruses. So SCADA system, they may get infected. So in this way, entire communication, it may crash. So now next is preventive action plan. So to prevent the SCADA failure, we have to ensure every hardware associated with a SCADA, we have to treat it like a critical assets. So always use a industrial grade PC or server. Check UPS and power conditioning. Perform weekly cleaning and health checkups. Disable auto updates during production hours. Related software thing: take regular database and system backups. Conduct disaster recovery test at every quarterly. While designing SCADA, implement the automated archiving of the database. Use modularized programming style so that it will reduce the garbage code in the PLC or SCADA. Handle memory allocation of the log file in the SCADA PC. For network infrastructure, use industrial switches instead of cost-effective office switches. Label all the cable and maintain network diagram. Use shielded Ethernet cables. Keep separate LAN or WAN for the SCADA. Keep IP address scheme updated. So now to avoid the human errors, we have to train the operator basic troubleshooting, implement the user role and password policy, use version control for PLC and SCADA, disable USB drives in the control room. So in this way, what we can do, we can control the failures in the SCADA. So always it comes from these small checks, consistent disciplines, these regular backups, clear SOPs, and also this genuine operator who help us to keep SCADA healthy. So if you like this video, please like, share and subscribe. Thank you.